Welcome to this comprehensive presentation on Drone Engage, a revolutionary solution that transforms how we approach drone operations. Today, we'll explore both the current capabilities and exciting upcoming features of this powerful platform. Whether you're a seasoned drone operator or just beginning to explore advanced drone technology, this presentation will provide valuable insights into how Drone Engage can enhance your operations with professional-grade tools and seamless integration. Drone Engage represents the culmination of years of user feedback and development, delivering exactly what the Andruav community has been requesting. This Linux-based board is designed to mount directly alongside your existing drone electronics, creating a powerful integrated system. Drone Engage excels in three critical areas. First, it enables FPV video recording using multiple cameras simultaneously, capturing comprehensive visual data from various angles. Second, it seamlessly transmits telemetry data to ground control stations like Mission Planner and QGroundControl, ensuring you maintain complete situational awareness. Third, it provides remote monitoring and control capabilities through the Drone Engage WebClient over the Internet, allowing you to manage your operations from anywhere in the world. You might be wondering about the complexity of implementing the light version. Let me address that directly with three key characteristics that define this system. First, it's remarkably small in physical size, requiring minimal space on your drone platform. Second, it's incredibly lightweight, adding only grams to your total payload, which means negligible impact on flight time and performance. Third, and perhaps most importantly, it's simple to operate, requiring minimal technical expertise to get up and running. These features combine to make Drone Engage accessible to a wide range of users, from hobbyists to professional operators, without compromising on capability or performance. Understanding the connection architecture is essential for successful implementation. Drone Engage connects seamlessly to various flight controllers, including Pixhawk, Cube, and OBAL RPI systems. The 4G GSM stick plays a crucial role by providing reliable cellular connectivity, ensuring your drone maintains communication even in remote locations. Drone Engage runs on the connected board and manages all communication protocols automatically. The OBAL architecture showcases the system's versatility, featuring a Raspberry Pi Zero processor, MPU 9250 sensors for precise motion tracking, and multiple interface options including USB, serial connections, and GPIO pins for maximum flexibility and configuration. The system architecture demonstrates remarkable scalability and flexibility. At the heart of the configuration, you'll find the flight controller board with its orange module connecting to a Raspberry Pi Zero board, which serves as the primary processing unit. The 4G connectivity module ensures constant communication with ground control. Depending on your mission requirements and complexity levels, you can expand the system by adding a standard Raspberry Pi board for enhanced processing power, or even integrate a more powerful computing platform like the Jetson Nano for advanced applications such as computer vision and artificial intelligence. These components work together seamlessly in various configurations, allowing you to scale your system precisely to match your operational needs. The light version system architecture provides a clear picture of how all components communicate. On the drone side, the 4G GSM stick connects to a Raspberry Pi board, which interfaces with your flight controller, creating a complete onboard system. All telemetry and video data flows through the Drone Engage communication server in the cloud, providing secure and reliable data transmission. On the ground control station side, operators enjoy multiple access options. The web-based interface displays satellite imagery and comprehensive mission planning tools, while traditional ground control software like Mission Planner provides familiar flight instruments and detailed navigation maps. This dual interface approach ensures operators can choose the tools that best suit their workflow and preferences. The Drone Engage video solution offers unprecedented flexibility in visual data capture. The system supports streaming simultaneously from multiple USB cameras connected to a single board, enabling comprehensive coverage from different angles and perspectives. But the capabilities don't stop there. Video streams can be aggregated from multiple Raspberry Pi boards, creating complex multi-angle video capture setups that would be impossible with traditional systems. This flexibility proves invaluable for various mission types, requiring comprehensive visual coverage, from inspection operations to surveillance missions, from agricultural monitoring to search and rescue operations where multiple viewpoints provide critical situational awareness. Testing your drone. Engage setup doesn't require physical hardware, thanks to software in the loop simulation. SITL, ArduPilot's software simulation environment, runs on your desktop machine, creating a virtual drone for testing. The workflow is straightforward. SITL sends Mavlink packets to Drone Engage running on a Raspberry Pi Zero, which connects to droneengage.com through your home network. Telemetry is handled using the Andruav web plugin, providing real-time data flow, just like a physical drone. Mission Planner can access the simulated drone through the Drone Engage WebClient, providing a complete testing environment that lets you validate configurations, test mission plans, and familiarize yourself with the system before deploying actual hardware in the field. Here we see the complete SITL testing setup in action, demonstrating how all components work together seamlessly. The Raspberry Pi 4 runs the SITL simulation, connected to a Raspberry Pi Zero W running the Andruav plugin. Communication flows through the Drone Engage communication server cloud infrastructure. Three key interfaces work in harmony. Mission Planner displays flight instruments and map data. The terminal window shows the Andruav plugin connection details and WebSocket adapter status, and the Drone Engage web interface presents the satellite map view. This integrated environment allows you to test every aspect of your system, from basic connectivity to complex mission scenarios, all from the comfort of your workspace. The multi-camera module architecture showcases the system's advanced capabilities. Any flight controller, whether Linux-based or STM32 ArduPilot board, connects to a Raspberry Pi 4 board running Drone Engage. The system comprises three essential software modules. The communicator module handles network communication, the Mavlink module manages flight controller protocol interactions, and the camera module processes video streams. The system supports streaming from multiple cameras simultaneously, with one camera connected via USB adapter to the main RPI 4. Additional camera modules can be added using separate Raspberry Pi boards, providing expanded coverage and flexibility. This modular approach allows you to scale your video capabilities precisely to match mission requirements. Understanding where each component runs helps clarify the complete system architecture. The ArduPilot firmware runs on your flight controller board, whether that's a Linux or STM32 ArduPilot board, handling all flight control operations. The main Drone Engage system, with its three modules including the communicator module, Mavlink module, and camera module, runs on the central Raspberry Pi 4 board, serving as the integration hub. Additional camera modules can run on separate Raspberry Pi boards for expanded video capabilities, allowing you to add cameras without overloading the main processing unit. This modular architecture provides exceptional flexibility, allowing you to configure your system based on specific mission requirements, from simple single-camera setups to complex multi-camera operations with advanced processing capabilities.